Let's switch us over to science and technology here. Let's watch a rocket launch. Is this the gameplay after that rage quit some days ago? This is still the same city.
Planning to land on the drone
if you're looking for abridged content, this is still the same city.
Falcon 9 274 times. And reusability is super important as it allows us to refly the most expensive parts of the rocket, which in turn drives down the cost of access to space.
It is a little windy out there.
Above the first stage is the second stage, which has a single Merlin vacuum or MVAC engine that ignites after the first stage separates. And that second stage is what will carry Merah Putih 2 into orbit. Speaking of the payload, Merah Putih 2 arrived in Florida in late January. And since then, the teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch. The payload is safely enclosed inside of the 17-foot diameter payload fairing, which is the large barrel structure with the pointed nose on top of the second stage. The fairing protects satellites on their way to orbit and are jettisoned approximately 3 minutes into flight. And the fairing is made of a carbon composite material. The fairing halves supporting today's mission are both flight-proven, with one half flying for its 10th time and the other half flying for its 11th time. And after separation from the second stage, both fairing halves will return to Earth and will be recovered by our recovery team. At T-minus 7 minutes and 44 seconds, Falcon 9 is tracking no issues and the payload is healthy. Falcon 9 has been loading propellants since T-minus 35 minutes and will finish loading at around T-minus 2 minutes. The range is ready to support and weather is green for our mission today. And if for some reason we don't launch today, we do have a backup opportunity tomorrow at 12:53 p.m. Eastern Time. For now, let's learn a little bit more about today's mission and the payload that's on board Falcon 9.
Okay. That's a pretty big sat. 4,000 kilos. It's 4 tons. Hey, Tech. Is all that foam there to insulate the components from vibration? It was a vibration testing chamber, an acoustic testing chamber. All the sound insulation on the walls, that's actually where they put the satellite through testing to basically try to break it. Yeah. If I'm thinking, Kibbles, if that's what I thought I saw. I don't know.
Our customer Telkomsat. Next up, the transporter erector, or TE, will retract away from Falcon. That's the large truss structure you see there standing next to the rocket.
So, since the stage that had the highest amount of flights was booster serial number 1058. 1058 had 19 flights before, unfortunately, after its 19th flight, rough seas tipped it off the drone ship and it fell into the ocean. Partially. SpaceX got some of it back, but yeah, the record is 19. With that being said, we did watch, which one was it? It was the SF-124 mission the other day. SF-124 used booster 1060. 1060 hit its 18th flight the other day. 19th is the record, but there are a bunch of boosters that are at 18th. In terms of the booster on Merah Putih 2 here, it's booster 1067. And the turnaround time was 44 days. This is its 17th flight. 17th. So 1067 is definitely up there. 1058 is the worm logo, yeah. Or was. Hey, Skydrift. How's it going? 55 months. 5 more months to go for 5 years. Love watching your channel. Go Falcon. Thanks, man. Drone ship for a geostationary 4-ton satellite. It's just geostationary transfer orbit erudite. GTO in terms of delta V, the transfer orbit is very high delta V. That takes a lot of energy to push that 4 tons that far. Your AP is 23,000 miles that way, or what is that? 32,000 kilometers that way. A 4-ton satellite, yeah, warrants that type of performance. Now, the interesting thing is that when SpaceX first rolled out with Falcon 9, Meraputty would have been a Falcon Heavy payload. Yeah. But since then, Falcon 9 has been stretched so much out to the Block 5 variant that a single stick Falcon with no boosters can just yeet that thing right to GTO, and they can reuse the stage by, instead of using the fuel that the booster would use to turn around and come back and land, they use that fuel to push the second stage to a higher staging velocity, which will get you more performance, and then the booster will just go and land out on the drone ship. How many Falcons are currently in active service? The oldest one, TARS, is 1060, and the newest one I've seen is 1082. Now, keep in mind there were some Falcon Heavy center cores in there, so that would be, what, 22 boosters? But there were 3 or 4 Falcon Heavy center cores in that count, so I'd say there's at least 15, at least, if I had to guess. Geostationary transfer takes not as much as the moon, but almost as much as the moon. Especially if you do a geostationary insertion. Geo insertion takes as much delta V as a lunar transfer. Oh yeah. But anyway, 16 previously flown boosters with a handful waiting for flight. Yeah, see, there you go. I wasn't that far off. Yeah, no problem, Tars. Yeah, geostationary transfer is it's a high energy. That's a high energy insertion. That takes a lot of power to do that.
Good call out for second stage LOX load completion, and the white cloud that's venting is venting from the TE LOX line, and that is totally normal.
Yep.
In about 30 seconds, we
ground gas closeouts.
Be sure that
they're evacuating the propellants out of this because the fuel and oxidizer lines for the second stage are in the transporter erector. You can't fuel through this first stage. That makes the plumbing more complicated. So the second stage fuel umbilical port is right there. So you need a fuel and an oxidizer line going up here, and then see that line right there? That's for fueling the second stage. When the second stage is fully fueled, they're evacuating all of the fuel out of here because you don't want this lighting on fire. You want the rocket to light on fire. At the bottom, not all of it. Hey Squish, 68 months. Note the white boxes that are at an angle on the side of the crew tower. Those are part of the slide wire escape. Oh yeah, I see the wires going down.
we just heard from the launch director that all systems are go for launch of Falcon.
Falcon 9 is in startup. T-minus 1 minute entered startup, and launch director reports go. T-minus 30 seconds.
T-minus 30 seconds.
I just said that. Chat reports go. 20 seconds.
T-minus 15.
10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3,
Sound suppressor is
2,
on.
1.
Ignition.
And lift off.
And we got a lift off. HTS113BT, Maraputty 2. On its way to a geostationary transfer destination.
Vehicles pitching down range.
Good. Reports good chamber pressure there. Vehicles begun to pitch and roll. Next call should be for nominal power and telemetry at T plus 43 seconds. Great tracking
At T plus
shot
30
here.
seconds and counting, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying the Meraputty 2 payload. During ascent, we tilt the engines, also known as gimbaling, and that
Power
turns the
and
rocket
telemetry
horizontally
Good
in
call.
what we call a gravity turn. In a gravity turn, the vehicle is still going up, but now we're
Stand
also
by for
heading
supersonic.
horizontally away from the launch pad.
1,000 kilometers an hour at 6.8
Moments
kilometers in
ago, we
altitude.
throttled the engines down in preparation for max Q, or maximum aerodynamic pressure.
Supersonic. Past Mach 1.2. Stand by for the call for maximum aerodynamic load, or max Q. There it is.
Just heard, we had max Q. And
Okay,
the rocket typically
engines
needs to
throttling
go
back up.
17,500 miles
windy.
per hour horizontally in order to avoid being pulled back
See how
down
the
to Earth and get into orbit.
Booster's oscillating around a little bit. It's wind. You see how it's kind of, if you look at it relative to the cape behind it, it's kind of doing this, windy. Okay. T plus 1 minute 40 seconds. Rocket's now going faster than 3,000 kilometers an hour, 26 kilometers in altitude.
And we have 3 events coming up in quick succession, starting with MECO, or main engine cutoff, stage separation, SES1, or second engine start 1. And that's coming up in around 30 seconds from now.
The plumes coming out of the first stage getting larger as Falcon 9 gets further and further out of the atmosphere. Pressure drops. Next step here is stage separation and upper stage ignition, or second stage engine start 1, SES1.
Vehicles on the nominal trajectory.
Guidance and control reports nominal trajectory. 91 knot wind at 12 kilometers. Yeah, it's windy. You can tell it's pushing the booster around. The guidance systems are compensating, though.
Main engine cutoff.
There's main engine cutoff for MECO. Helium purge out the first stage.
Confirmed.
Clean separation confirmed. Upper stage ignition,
And there you
SES1.
heard and even saw those 3 events that happened back to back, which are MECO,
Good.
stage separation,
Stiffener
and
ring
second
separation
engine start
confirmed.
1.
Okay.
Coming up next will be fairing separation.
Looking good. First stage now decelerating at 7,900 kilometers an hour, 87 kilometers in altitude, coasting to its apogee here. Second stage crossing 8,500 kilometers an hour, 94 kilometers and ascending. Second stage engine looking good. What's the payload? The payload is the HTS113BT satellite. It's an Indonesian telecommunications satellite. You can call it Merah Putih 2 or 2. Yeah, there's no stubby nozzle this time around, guys. They need the performance. Stand by for the call for fairing separation.
Confirmed.
Fairing separation confirmed, exposing the satellite to the vacuum for the first time.
We just saw fairing separation.
T plus 3 minutes 40 seconds into the flight. Second stage now at 9,400 kilometers an hour at 120 kilometers. First stage is coasting to apogee here, 7482 kilometers an hour at 115 kilometers. Fairing is vented, yes. Everything looks good here. Keep in mind, the magic number here that they're looking for on a geostationary insertion is above 27,000 kilometers an hour. That's really what we're looking for here with the second stage. But they might put this into an insertion orbit. They might put it into a parking orbit. So we're looking for something north of 26,000 here. Okay.
3 M1D.
Okay, 4 minute 30 seconds into the flight. First stage has hit apogee here, 7,400 kilometers an hour at 119 kilometer apogee. Pretty high apogee compared to Starlink there. That means it's at the height of its ballistic arc. Earth's going to pull it back down. Meanwhile, the second stage over here at T plus 4 minutes 50 seconds is at 11,600 kilometers an hour, 150 kilometer altitude.
And this causes the vehicle to fly through Merlin's exhaust gases, which are also known as the plume, and this deposits a layer of soot on the vehicle surface.
Pretty high apogee there.
And that soot comes from the carbon-based fuel, the RP1, that Falcon 9 burns, and with each flight, the soot builds up a little bit more on the outside of the vehicle.
I'll tell you in a second.
Oftentimes, prior to launch...
So what's going to happen here, Falcon 9 is going fast enough. The first stage is going fast enough to experience entry heating. We're probably not going to see it because the sun's out, because they launch during the day. But at night, you could see plasma accumulation on the vehicle. Falcon 9 doesn't have any tiles or like an ablative heat shield like you would have on a pod. The reason why is because, well, that stuff will weigh you down. right? It'll weigh you down, and it adds complication to the vehicle. So how does Falcon 9 come back down without having a thermal protection system? Well, first of all, if we want to get really nerdy, it does have some thermal elements on the bottom of the vehicle. But the biggest thing here is what we're about to see. What we're about to see is the entry burn, or supersonic retropropulsion. You want to hear something crazy? What the first stage does, it fires its engines. Fires its engines to slow itself down. But also, outgassing at the business end of the vehicle, so the part of the vehicle that's flying first, is going to actually push the reentry plasma that is the result of atmospheric ionization from compression, basically from it flying through the air. It's going to fire its engines here, and that's going to push the reentry heating away. It pushes the plasma away. That is using the rocket's business end and the rocket exhaust as the heat shield. And there it is. 6 minutes, 40 seconds. The entry burn is still going. First stage is decelerating 5,200 kilometers an hour at 45 kilometers. Second stage is crossing 18,000 kilometers an hour at 167 kilometer altitude.
So on the left-hand side of your screen, we have stage 1. You could see that it really decelerated as its speed slowed down.
I never understood the speed of the first stage to what. This is probably relative to what's called a reference frame, where it took off from, Danzu, if I had to guess.
First stage that's supporting today's mission will perform this entry burn.
Hey, wait,
in
104
time.
months. So the entry burn is completed here, and now the grid fins are basically going to take over here. The grid fins really stretching this thing. What Falcon 9 is trying to do right now is it's trying to maximize its flight time here with the grid fins kind of pitching it up a little ways. The reason why it's trying to do that is that if you're coming down like this, you're not going to be able to use as much of the atmosphere to slow down. If you notice, she's decelerating like crazy. Inside 6 miles off the ground or 10 kilometers up, it's decelerating like crazy. The more flight time that first stage has in the atmosphere with the grid fins, the more time it can use to slow down. It came back from 120 kilometers up. That's a long way. Even with the entry burn, it still seemed like it was stretching its trajectory there, which is good. That gives it more time to slow down. And now when the landing burn starts, you're really going to see the thing pitch kind of upright and get kind of perpendicular to the drone ship. Drone ship should be somewhere underneath the left grid fin right here. Okay, at 8 minutes, 10 seconds, we have second stage engine cutoff. First stage landing burn has begun. First stage, 700,
Nominal park
600,
insertion.
500. There's a call for good insertion. It's very windy out there, guys. Very windy. Grid fins are doing real work, but Falcon 9's coming down right over the X. Landing legs have deployed. Good landing. T plus 8 minutes 38. First stage back on the drone ship.
That landing marks SpaceX's 275th recovery.
That was a little shady.
Including
it is very windy out there. See the white caps on the ocean.
Our second stage engine before we're ready to.
The white caps on the ocean. It's windy, very windy. Why is this booster all black? Well, Sneaky's Neck, good call, a good question. That's carbon soot from the engines. Falcon 9 is using kerosene and liquid oxygen. We did get a call for nominal orbit insertion. Now it's going to coast here for a second. 26,949 is second stage engine cutoff velocity at 164. Second stage, slight deceleration probably from one of the thrusters. Anyway, why is it sooty? It flew through its own exhaust. Like if you have a big truck and you see the big truck and you see the black smoke come out, that. Falcon 9 does that. They run very fuel rich with the booster on purpose to keep the engines cool. If you flood the engine with fuel and some oxidizer, you get a pretty good explosion, but it keeps the components at a lower operating temperature so they don't melt themselves. Particularly the turbo pump system, what's called the gas generator on the Falcon 9 engines. Falcon 9 uses what's called a gas generator Carolox. Gas generating cycle using kerosene and liquid oxygen, or Carolox for short. What you basically have is a jet engine. Think a jet engine. Jet engine produces thrust, right? This isn't even the rocket engine part. They have a jet engine on board, but the jet engine doesn't pull in air. It has no compressor wheel. There's no need for that because you can use the liquid oxygen, right? And you're not going to be able to have an air intake on that thing either because where the rocket goes, there's no air. So You have a jet engine that has not only a fuel injector like a jet engine into the combustor, but you have an oxidizer injector. And they combine the fuel and oxygen in this gas generator, and it explodes, obviously, like a combustor on a jet engine, or, you know, what happens inside of a car engine when the piston goes up and down. And that creates an explosion. That explosion gets forced out of a nozzle and turns a turbine wheel. That turbine wheel is attached to two fluid impellers, two fuel pumps, but it's fuel and oxidizer. So it's a fuel pump and an oxidizer pump. And those two impellers are what's pumping the fuel into the engine, right? Hence the name, turbo, turbine wheel with a gas generator, pump, fluid impeller moving your fuel, turbo pump. Or you can call it a power pack on the side of the vehicle. Now, each one of these power packs, the liquid oxygen that gets sprayed into that gas generator is pretty damn cold. It's like minus 290 or something. It's pretty cold. But the explosion that happens to get that turbine wheel to spin at extremely high RPM to be able to feed the rocket engine with fuel, right? It makes it pretty dang warm. So they flood it. They run it fuel rich. Running fuel rich means that some of that fuel that they spray in there isn't used for combustion, but it's used to absorb the heat from the fuel that does blow up. And that ends up making a lot of unburnt carbon come out of the bottom. And when Falcon 9 is flying backwards, it flies through 3 engines worth of its own soot. It rolls coal. That's what I'm trying to tell you. And that's why it ends up being all sooty. Now, the funny thing is that the soot really only attaches to the RP1 tank. It adheres to it. What happens is that above a certain level on the second stage, the soot actually ends up adhering to the ice because the liquid oxygen in there is super cold. So when Falcon 9s come back down and land, you usually see the kerosene tank on the booster really, really dark, and then the liquid oxygen tank really, really light. Because it didn't adhere to the tank, it adhered to the ice on the tank. So right now the second stage is coasting. They did go into a parking orbit at 168 kilometers, but we don't know it's actually circular at 168. We're not going to know until it acquisition a signal through Gabon. SpaceX has a ground station over here. Yeah, I got you, Snake. This is what I do, guys. This is my favorite thing in the world, dude. Yeah, Jacob. That's only for Prime subs, Dunpeel. The Partner Plus program basically offset any potential losses that I'm going to get, and then some. Yeah, it's not as... If you have a lot of Prime subs, you're going to suffer, but once again, I will tell you guys this. I am Partner Plus. The best way to support this stream would be a tier sub and not a Prime sub. Now, don't be compelled to do anything. I don't expect anything from anybody. You don't be successful in this business expecting your community to pay you. Don't expect money. That's not how you stream. I've been doing this for a decade. That's not a way to do it. You earn it. So if you do want to support the stream, tier 1, tier 2, tier 3 subs are a 70-30 split. It's a great way to support the stream. Are you going to do a KSP1 stream soon? Maybe, Cirrus. Yeah. What happens to the second stage after it deploys the payload? Good question, Arian. So their insertion
Discovery,
after second stage engine start and then second stage engine cutoff and satellite deploy. The insertion trajectory, right, it has what's called a high apogee. The apogee is at geosynchronous or geostationary, geostationary, and your perigee is still down in low Earth orbit. What's apogee and perigee for the people that don't know? One of the defining characteristics of an orbit is what's called apoapsis and periapsis. The name of the AP and the PE change depending on what planet you're orbiting around. It's better for distinction. So, like, if you're going to say, apoapsis around Earth. No, that's called apogee because Gaia is, or it's the etymology of Earth's Gaia, that's the name. So, around the moon, it'd be apolune because the moon is Luna. Around the sun's name technically is Helios, derived from the Greeks, right? So, Around the sun, highest and lowest point in your orbit is your aphelion and your perihelion, right? Pretty straightforward stuff. So, the insertion altitude, the insertion apogee for the second stage after the engine cutoff here. Hey, Jizzlefy gifted a sub to Focus, and G Crusader had a 3-month resub. Thank you. So our insertion apogee will be around geosynchronous. So that's 23,000 miles, 23,500 miles, or about 32,000 kilometers that way, right? Your PE, your periapsis around Earth, or perigee, is going to be, should be around 168. Now, why? So what, is the second stage just going to be stuck in that orbit? Well, no. You don't want uncontrollable debris up there. The second stage doesn't have any solar panels. Why? It doesn't need solar panels. It's not a satellite, it's a stage. So you want to find a way to get rid of that stage. How SpaceX does it with the geostationary transfer orbit insertion like this is keep the perigee low. So the second stage will deploy the payload, it'll basically fly out there with the satellite, and then in about 6 hours it'll do one orbit, come back down, and re-enter. They could do some precise course corrections with the second stage to get its perigee low enough so it burns up. Danzy with the prime sub and Apollo with a 15er. Thank you. Do the two shields that opened up and fell away burn up on re-entry or just splash down in the ocean? They are large and heavy, right? So Charles, those are called fairings. The payload fairings are actually super light. How is it super light? They're made out of carbon composite and aluminum honeycomb. Think about like if you had a Hydrox or an Oreo cookie and you cut it in half and you saw like, you know, the top part of the cookie, the bottom part of the cookie, and then the center, right? There's a ground station relay. Watch these numbers. They'll update when they have reacquisition of signal. So the fairing is basically aluminum in the center. That's the filling, so to speak, with carbon fiber wrapped around on it on either side. That makes it super lightweight. And because those fairings are super lightweight, they have a low enough ballistic coefficient and a high enough coefficient of drag to not need much thermal protection. Think about it like this. You're on top of a building, right? You have a piece of paper and you have a brick, and you drop both of them, right? What happens? Well, the brick's gonna go right down to the ground really, really quickly. The piece of paper is just gonna, and then eventually it'll get down to the ground. It's gonna take a lot longer, but it'll get down there, and when it gets down to the ground, unless it doesn't get stuck in a tree or something, it's just gonna land, no problem. And you'll have a relatively intact piece of paper. SpaceX figured out that with some guidance and control systems, if you reorient the fairing the right way, it'll do exactly that. And they'll land out in the ocean and they fish them out. Now, how did they do that? How did they figure that out? Well, most fairings use compressed gas for their separation system. You need those fairings to basically separate really, really quickly, and any Kerbal player knows you don't want them hitting your payload, and you definitely don't want them hitting your stage. Any KSP player knows exactly what I'm talking about. It sucks when you don't get the jettison force right. So, the simplest way to get those fairings to separate is to decompress gas. Is gas thrusters, but it's gas thrusters like think if you have a compressed air hose and you go pss, 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 like that. They're gas thrusters that shoot the fairings out and away to the sides, because like I said, the fairings are light, but they're not that light. Those fairings can fit a school bus inside of them. They're about, I don't know, 3 to 4 tons. They're still pretty dang heavy. They have a lot of mass. You know, like you and I can't move one around. You'd need a truck to do it, right? And a crane to pick it up, because actually it's super flimsy if they're not coupled together. Super flimsy. So SpaceX thought, well, we're using a pneumatic system. We're using compressed gases to push the fairings away from each other. Why not add a little bit more gas into the tanks on each fairing, right? And then put a little thruster system on board to get the fairings to turn, right? So the outside aerodynamic part is the part that hits the atmosphere. So that's what they did. The fairings have little reaction control system thrusters on it that are using the compressed gas that's already there on the fairing to steer themselves down and land. And they're basically right before that fairing comes down and hits the ground, there's a parafoil. There's a parachute. It'll deploy a parafoil, and then the thing will just kind of land like a seaplane almost. And then SpaceX has a gigantic recovery ship that has a huge crane on it, and that crane basically has a fishing net. And they sink the fishing net underneath the fairing and then pick it up and put it on the ship. Here, show them this. Yeah. See? There you go. Pretty cool, huh? That's a picture of them fishing the fairings out. The thrusters keep this part of the fairing, the curved part of that fairing, facing downward, because if they re-entered the other way, right, it would fry all the computers on the inside of the fairing. These things have some type of primitive guidance system in them because they need to know where the water is, right? They need to have an altimeter, some type of flight computer on board, right? But yeah, that's how they recover them, dude. Fairings, we've heard from SpaceX over, you hear not whispers from people, but a lot of people that work at SpaceX, higher ups at SpaceX, post on Twitter and stuff. They've said that, I've heard that there are certain fairings that have over 10 flights on them, which is pretty insane. Now, here's the thing. Why? Why are you reusing your fairings? Like I said, it's a very light part. It's not that much of the cost of the entire vehicle. Falcon 9 as a whole, with a reused first stage, from what we know, it costs about $40 million. The fairings probably make up maybe $4 to $5 million of that $40 million. First stage, second stage, payload fairing, etc., etc. It's about $4 to $5 million a pop for the fairing, right? What's pretty cool is your explanation. Thanks, Miko. Right? So, why bother to reuse the fairings? Why would you do that? Flight rate. Fairings are a production bottleneck. They take time to make. Remember, I told you it's like a cookie, right? The reason why I said it's like a cookie is because you have to bake the fairing like a cookie. Fairings are made in an autoclave. An autoclave, basically a Mack truck-sized pressure cooker. Fairings you need to have your aluminum honeycomb, and then you use your aluminum honeycomb as what's called a mandrel, and you wrap the carbon fiber around that, and then you've got to bake the carbon fiber. Fairings need to be baked like a cake. They're not expensive to make, but they take a long time to make. And if SpaceX wants to launch, SpaceX knew this back in like 5-10 years ago. They knew that with a higher flight rate, fairings would become a production bottleneck. So reusing them isn't necessarily a monetary thing. They don't reuse them to save money. They reuse them because they take a long time to freaking make those things. It's a complicated piece of equipment. Not expensive, but complicated. I don't know, RJ, probably. Per Elon, the fairing is like 6 million. Yeah. Good pick of the fairing for size. Yeah, fairings are... Yeah, that's a good picture. I'm going to use that one. See? Those are Iridium satellites. That's not Marapudi, but that's the same fairing. And if you look closely at this, you can see the pneumatic lines for the separation system. You see the pneumatics right there? Those, you could just barely see them. And there should be another one down here somewhere. Yep, see the pneumatic line? That's a little air line right there that fairing shoots off. Yeah, this is an older fairing design. The vents, the vents are in the wrong place. Yes, Creeper, I did. Do they use different size fairings? Nope, Zymus. It is easier and cheaper to make one fairing. Falcon 9 and Falcon Heavy both use the same fairings. Now, why? Why would you use a single type of fairing? One assembly line, dude. Think Factorio. One assembly line makes one fairing, one size fits all. You could put a Tesla Roadster in here, or you could put a satellite the size of a school bus. I only know because... I only know because they absolutely did that. That's not photoshopped. The Falcon Heavy test flight, for the people that didn't know, launched Tesla Roadster serial number 1 into space. Because Elon. Yeah, one size fairing fits all. However, fastest car ever. That's correct. That thing is somewhere in an orbit between Earth and Mars. They launched it at Mars, but Mars wasn't there when it got near Mars's orbit because that's because of what's called orbital phasing. Long story short, when you're shooting a payload off to Mars, like if you're playing a first-person shooter, you got to lead your target. Yeah. If you don't lead your target, you're gonna miss, and it missed. Not because Mars wasn't in the right spot. If Mars is on the other side of the sun's in the way. You don't want to shoot this at the sun. You're not. I mean, you could. Probably didn't want to do that. Anyway, so yeah, it's somewhere between Earth and Mars. The sun probably melted it by now, to be honest, guys. Heat is a huge problem in the vacuum, but that's another story. And orbital phasing is another story as well. Now, Uncle Sam has some use for SpaceX and some use for a bigger fairing on board Falcon. I'm not 100% sure why, and I don't think we'll ever know, but here, check this out. The Space Force is paying SpaceX to develop a much bigger fairing for Falcon 9. That's the one that I just showed. That one. So, Uncle Sam's paying SpaceX to do something with that bigger fairing. So, Falcon 9 will have the ability to have 2 different types of fairings. So, let's keep up here. We're coming up on second stage engine start. Mission elapsed time T plus 2741 here. Second stage velocity 26,391 at 292 kilometers. What you're seeing here and why it looks like it's snowing is what they're doing is they're priming the engine. Priming the second stage for flight. You're trickling your propellants back in. One of the propellants, liquid oxygen, very cold. You have to make sure that your turbine machinery, which was sitting in the sun, it's a little warm now, is to the right operating temperature. You don't want to flash freeze it. That would be very bad. So we do have a good ignition here at T plus 2812. Good ignition, and we had a loss of the signal feed there. It looks like it went over the hill. Oh no, we have a reacquisition of signal.
So we just had confirmation of second stage burn of the MVAC engine.
It was
on
a
second
ground
stage.
station relay.
And before we go to coast, let's learn a little bit more about today's mission. Telkomsat has chosen the Thales Alenia Space as the prime contractor of the satellite for on-ground delivery and making it in charge of early orbital positioning and in-orbit tests. Built on the Spacebus 4000B2 platform, Merah-Putih 2 will provide a capacity of more than 32 gigabits per second and a service life of 15 years. This is Telkomsat's first...
So yeah, Charles, a lot of good questions from you. That snow that was coming off, it looks like snow, but it's not. It's just solid oxygen. It's not solid H2O. It's solid O. Because when you outgas, so what they're doing here, there's engine cutoff. What they're doing now, you see that thing is going again. But you see stuff isn't really freezing, per se. But if you have liquid oxygen and you outgas liquid oxygen into the vacuum, for a split second, that oxygen is not at absolute zero. Absolute zero is the vacuum. 0 Kelvin. Nothing. The absence of heat, the absence of everything. Right? But for a split second, that liquid oxygen will go through what's called phase change. It'll solidify. Why will it solidify? Because that oxygen exists as a liquid, and if you wanted to make it solid, you would freeze it more. Now, what happens if you take a liquid at pressure and you vent it into a vacuum? No pressure. It's going to phase change for a split second. While that heat gets pulled out of it, because you're in the vacuum, it'll pull all the heat out of it completely, and you get solidification just for a second. But because you're in the vacuum, it'll solidify, and then it'll just stay like that until the sun melts it. Yeah, see all that? That's solid oxygen happening right there. Now, how did they get the vent lines going? How did they do that? Oh, we're getting some signal disruption here. There's a lot of artifacting going on this camera. Now, how did they what the heck was that? I'm wondering if the satellite is facing down towards the planet right now. It's hard to tell. Now, how did they get the solid oxygen out of there? They got the solid oxygen out of there because there are helium tanks on board the vehicle, and what they do is they pump the engine, they purge it with helium because you don't want residual combustion in here, because if the rocket engine burps, right? If it burps, that could screw up your staging velocity, and you could shoot the satellite into an orbit that the customer doesn't want. That's not going to end. That will end very bad for you. Also, you're using liquid oxygen here. Last time I checked, oxygen oxidizes things. It makes things rust really bad. Anybody that lives in the salt belt knows that if you have H2O plus salt plus metal, yeah. If you have Fe, right, combined with NaCl and H2O, you get a lot of iron oxide. Liquid oxygen oxidizes things. Funny how that works. You don't want the engine rusting from the inside out. That's why they purge it out with helium. So the next time they go to start it, they'll start trickling the propellants in to cool the engine down and prime it, and then they'll fire it again. That's why you see it venting after ignition, because they're trying to make sure that the engine, if they need to use it again, right? And it's just good procedure to do it. To make sure that the engine doesn't rust itself from the inside out. You don't want any surprises here in space. It's really easy to get surprises in space, and you don't want that. So they vent the engine out after the ignition. So we have a good insertion here. We're coming up on satellite deploy. Mission elapsed time is T plus 32 minutes 40 seconds. Second stage velocity is 34,910 and decelerating. The altitude is going up. This indicates a eccentric orbit here. If your altitude's going up and your speed is going down, that means you're going up. That means you're going up and Earth is trying to pull you back. Earth's gravity is trying to pull this thing back towards the Earth. If you have altitude going up and speed going up, that means you're firing. That's lightning. That's what those blips are. That's lightning. There's a thunderstorm on the other side of the world somewhere in Africa. Dun 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 dun. Dun 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 dun. Oh, there's some solid oxygen shooting off the sides. Herpa derpa derpa derp derp Africa. Sorry. Missed an automaton opportunity? Alright, fine. No, that's not the right key. Good enough. High five. Happy time. Coming up here on deploy.
Successful landing of Falcon 9's first stage on the drone ship. Just read the instructions, which mark the 17th landing for that booster.
Yeah, you can click on the link in chat to see where Starman is. But we're coming up on deploy. You should see a ring here separate. There it goes.
Payload separation confirmed.
Good deploy on Meraputty.
An awesome view and confirmation of payload deployment of the Meraputty 2 satellite.
Sweet. You'd see the satellite has its own little maneuvering engine on there. Fun fact, that looks like a Hall effect thruster. That's an ion engine. Any Star Wars fans out there? TIE Fighter, twin ion engine? That's a single ion engine. They exist in real life. They just not nearly as powerful as the ion engines that are in Star Wars. Yeah. What kind of satellite? This is an Indonesian telecommunications satellite.
All of us here at SpaceX want to thank our customer, TelcomSat, for entrusting us with today's mission. And we also want to give a shout out to the Range and Federal Aviation Administration for supporting today's efforts. That'll conclude our webcast coverage of SpaceX.
What kind of cameras? SpaceX has their own in-house optics, so it's a custom engineered lens, Willie. Fun fact, SpaceX back in the day just used GoPros. They just strapped some GoPros next to their... Yeah, just strapped some GoPros to the rocket, quite literally, because they couldn't engineer their own cameras in-house. Mo Diggles, hey EJ, more recently started following you, love the content, my pleasure. I'm just a big nerd, dude, that's what I like. This is the kind of stuff I love. The stream got successful from me playing tons of Kerbal Space Program. I've been on a workers and resources kick right now, but yeah, Kerbal will always be my first love. Love that game. But yeah, great landing. Good mission, good insertion on the satellite. Congratulations to SpaceX. Congratulations to Telkomsat. Good stuff. High fives all around. Wait a minute. That's somebody else's thing. Never mind. I love space stuff. I know nothing about it, but I work for a space company. All right. That's cool, man. Right on. Neat. Oh, yeah, right. Miko! Hey! Thank you. Tips are necessary and expected. Thank you for your education. Happy time! Greetings from Deutschland to all. Oh, hello, mein Freund. Hallo, wie geht's? Ah, ist gut. Good. Very good. That was Germglish. English and German. My job controls the Parker Solar Probe. Oh, that's cool, Mo Diggles. Right on. PSP is probably my favorite NASA mission. You know why? Because I like things that go fast. Nothing that we've made is going faster than Parker Solar Probe. That is the fastest thing we've ever made. Ever. How fast do you ask? Mo, I know you know this, but just for everybody else, how fast does PSP go? 430,000 miles an hour. It's pretty fast. I actually stood at one point, because I have friends at ULA, I stood next to the Delta IV Heavy Parker Solar stack. Yeah, stood next to it. Yeah, so Parker Solar holds a pretty good place in my heart. That's awesome, dude. My absolute favorite NASA Science Mission Directorate mission. It's fantastic. Because America's about speed. Hot, nasty, badass speed. It's a quote. I was quoting Eleanor Roosevelt. You think I'm kidding? Look. Here. See? I saw this in a movie once, so it has to be true. Hey, Laserman, your German is almost as bad as mine. Oh, danke. And let's just leave this up on the stream here for a second to make sure that it thumbnails. So anybody that's in the science and technology category sees this as the thumbnail and get very confused. Here, I'm just gonna stay like this so it thumbnails that. Tell me when it thumbnails it. Go ahead.
Discovery, go at throttle up.
Cloudy Chicks, thank you for sharing your knowledge on anything and anything space related. Love to lurk here. Oh, you're welcome. Yeah. Got it? Are you good, Narden? Yeah? Not yet? Dang it. Just telling you, telling you. There it is. Are you good? Are you good? Yeah? Keep going? Alright, okay, I'll just sit here. It's good. Don't stop. Is this like planking? Yeah. Sure. Almost there. Luke, you switched off your targeting computer. What's wrong? Nothing. All right. Thumb a little bit closer to the camera. Here, how about we do the meme that... Oh. Yeah. Yeah, it's good. It's working, right? Yeah, yeah. Yeah, are we good? Did I get it? Hold! Down in hands! Need the red arrow. Need the red arrow. Got it? Oh, excellent. Excellent, excellent, excellent. Nice underbite. You got it? All right, perfect, perfect. All right, cool. That's going to conclude the coverage for the HTS113BT launch. Congratulations to everybody involved. I'm going to go back to playing workers and resources. Did we get it? You got to stop this. No. No. Oh, God. Oh, you can see my crooked teeth. Dude, I swear if it thumbnailed me when I was looking at chat. Yeah, that all right. That works. It works. It's good enough. It's good. It's fine. It's fine. Relativity. What's up with relativity here? I'm gonna switch us back over to workers and resources here. I'm gonna try to get out of this debt spiral that we're in workers and resources.